Controls explanation. Here we can see controls for the visual reality headset Oculus Quest 2 controllers. With a left joystick, user can move around the scene, while with the right joystick, user can turn. Grabbing of objects is conducted through grab trigger, but currently there are no grabbable objects in the scene. To interact with the scene, user can utilize both left and right pinch triggers. Once user aims towards the user interface to select the visual impairment or color vision deficiency simulation, they can disable that visual simulation with press of primary buttons on both left and right controllers. This will allow user to navigate the scene more easily. To know when user can or cannot interact with certain object, there are rays visible in the scene. Straight ray lines denote the interaction with user interface and physical objects, while curved ray lines denote the teleportation option in the scene. For the straight ray lines, blue denotes the valid selection aim, while purple denotes the invalid selection aim. For the curved ray line, green denotes the valid teleportation aim, while red denotes the invalid teleportation aim. Welcome to the visual impairment and color vision deficiency simulation. There are two tests to carry out as a part of a simulation. Test A: modifications of user interface elements with each visual impairment. And Test B: individual correction, stroke and pattern placement with each color vision deficiency. Test A is directly interactable and outputs will vary based on the currently equipped visual impairment simulation. Test B is conducted as a survey with a set of suggested changes to the overall game scene. Based on the currently equipped color vision deficiency simulation, user has to note down which of the suggested changes may contribute to the better understanding of the game environment. Tasks. There are 3 steps user needs to follow to conduct a simulation. Number 1. User needs to select either a visual impairment or a color vision deficiency simulation on the following slides. Number 2. Based on the simulation selected, either visual impairment or color vision deficiency, user then needs to proceed to carry out either Test A or Test B, respectively. Number 3. User is to take screenshots of changes made to the UI for each visual impairment and note down which of the suggested changes aid the color vision deficiency simulation. Visual impairment selection. User is to select one of the visual impairment simulations presented here. It is important to note that these simulations and the way they are presented are the product of thorough medical research and papers. However, these simulations are not intended to provide a universal representation of disease symptoms. Individual manifestations of symptoms for each visual impairment or color vision deficiency can vary significantly between patients. Selecting no visual impairment removes any simulated visual impairment. Selecting age-related macular degeneration simulates distortion, overall blurriness, darkening in the visual field, and desaturation. Once simulation is applied, looking to the upper left corner, user can see which visual impairment or color vision deficiency is being simulated in the moment. As mentioned before, each simulation can be temporarily turned off. Selecting cataract simulates distortion, overall blurriness, desaturation, and a yellow tone. Selecting diabetic retinopathy simulates overall blurriness and dark spots. The spot position and size of dark spots is arbitrary and may not resemble individual real-life impairment symptom. Selecting glaucoma simulates peripheral vision loss. Color vision deficiency selection. User is to select one of the color vision deficiency simulations presented here. As on the previous slide, user can disable simulation by selecting No CVD. All of the colors will be visible. Selecting tritanopia simulates insensitivity to blue light. Selecting protanopia simulates insensitivity to red light. Selecting deuteranopia simulates insensitivity to green light. Selecting achromatopsia simulates lack of all color vision. Test A. Modification of UI elements. User's task is to click and drag user interface elements, including example buttons and titles, to the position that may suit the current visibility. Anything with the orange color, shown here, can be moved around. On the first screen, user is met with the title screen of the game. Such screens usually contain the name of the game or game title and a short statement of which button they need to press in order to progress towards the main menu of the game. On the second screen, user is met with the simulation of main menu in a video game. The most common buttons found in video games are those that start the game, play button in this case, let you adjust the game settings, options button, and let you quit the game, exit button. The exact names of these buttons can vary depending on the specific game. Starting the visual impairment simulation tests. The following video sequence will play the simulation in action, where user adjusts the UI according to each visual impairment applied. Test B. Simulation of color vision deficiency in games. User's task is to observe images on the following slides and note down whether any of those could be substitution for the current color vision deficiency simulation applied. The images are as follows: unedited image of a game with alteration of a hue by 90 degrees, image of a game with alteration of a hue by 180 degrees, image of a game with increased contrast, and lastly, an image of a game with outlines around characters, which depict the example of a shader. All of the images are the same in content. On the left-hand side of the test B, there are two images visible: color vision deficiency diagrams and color vision deficiency tiers based on severity of the condition. These are purely informational and do not take place in the test B. Starting the CVD simulation test. The following video sequence will play the simulation in action, where user goes through all of the images for each color vision deficiency applied.